So here I have written a print array function. This function will basically print the content of an array, okay? Array called R of size n. And then here we have a sample array that has 6 elements, and we're going to print those 6 elements. Now let's write the merge function, the merge sort function. Let's start with the merge function, okay? Because we're going to call the merge function using the merge sort. So merge is a dependency. For that reason, we have to start with it. So we said that merge is a function that is of type void because it doesn't return anything. It's called merge, and it takes an array, and it takes the beginning index and the end index. And we said that the first thing we need is basically a variable called m, which takes the beginning plus the end divided by 2. And we're going to create a temporary variable, a temporary array. So that's tmpr of size beginning and minus beginning plus 1. Okay? And we declared 2 variables, I equals the beginning, I starts at the beginning, and j starts at m plus 1. Okay? So I started from the beginning up to m, and then j started from m plus 1 up to end. So while I is less than or equals to m, and j is less than or equals to end, so we said that we're going to copy inside the temporary array of index k. Let's declare k. So k takes 0 initially. So the temporary array at index k, and every time we copy something into that temporary array, we're going to have to increment k, so let's add the plus plus there. So TMP array of k plus plus would take the element, whether it's array of I or array of j. So let's add an if statement there. So if array of I is less than array of j, it means that we have to copy array of I. So we're going to copy array of I plus plus. Because again, of course, whenever we take an element from an element pointed by I, then we have to increment I. So that next time, whenever we talk about an element pointed by I, we're talking about the next one and not the previous element that we already copied so far. Else, we're going to copy inside the temporary array of index k plus plus array of j. And of course, we have to increment j whenever we read an element pointed by it. Cool, so this would keep merging the elements, copying the elements. But now we have to deal with this situation if the arrays were not copied. So it means some of the subarrays was not copied fully. So basically, while I is less than or equals to m, then we're gonna copy the temporary array of k plus plus. We're gonna copy inside that location array of I plus plus. And there's no need to use those curly braces since it's just one instruction. And let's copy that and do the same thing with j. So if j is less than or equals to and, then basically we're going to copy array of j plus plus. Now that we have the temporary array containing both subarrays merged, we have to copy that array back to to its original location. So for I starts at 0 up to k, we're going to say that array of beginning plus I would take the temporary array of I. Now we have the merge function. We can test that function if we wish. So let's test that out. So I'm going to create a sample array. So array of, let's say 1, 2, 3, or let's say 1. All right, the array is of size, let's say 4. And the elements inside it are 1 and 3 and 2 and 4. So let's merge that array. The beginning is at index 0 and the end is at index 3. And let's see whether it got merged or not. It has 4 elements. And as you can see, the array got merged, though. So that's 1, 2, 3, 4. Cool. So our merging function is working correctly. Okay. So the only thing remaining here is to call that function using the recursive divider function that is called merge sort. Okay. So let's do that. So our merge sort function takes an array and it takes the beginning index and the end index. Okay? So if the beginning equals the end, it means that the array is already sorted. There's no need to do any recursive calls. So just return. Okay? Because again, an array of size 1 is by definition sorted. Otherwise, if the beginning is not equals to end, in that situation, we're going to have to divide the array by 2 subarrays, and then we're going to merge these 2 subarrays. So let's do that. So we're going to merge sort. So the function is going to call itself, but with different indices. So the beginning is the beginning and the end is m. Let's compute m. m is the beginning plus the end divided by 2. So we're going to merge sort from the beginning up to m, and then we're going to merge sort again from m plus 1 up to end. And then finally, we're going to merge these 2 subarrays together, okay? These 2 subarrays. So merge the array and give it the beginning of the array and the end of the array. And this should sort the given array, yeah. So we have here a sample array that has 6 elements. So if we print the array is not sorted, as you can see. Now I'm going to call the merge sort function, give it the array, give it the beginning index and the end index. So since this array has 6 elements, then it is indexed from 0 up to 5, so that's 0, 5. And then let's print the array again. So R has 6 elements. And as you can see, the array is sorted. So that's minus 13, 23, 32, 43, 54, and 544. So that's a sorted array, okay? All right, so that's it for this video. If you have any question, feel free to raise a question. I'll be happy to answer that. And for the complexity analysis, I'm going to cover the complexity of this algorithm using in another lecture. The lecture should be titled something like the master theorem of proving complexity, something like that. So I'm going to talk about the complexity of recursive relations. Okay? And see you at the next video.